Yeah, just a reminder, you guys should follow your schedule and in the class. You have personal matters, you should sort it out outside the class time. Okay, now we are talking about optimization. So I'll be using material from this book. Just an introduction. I think you have been through all the introduction part for phrase or design. So we will have three phases in design. The first one will be doing feasibility studies. This is what you have carried out in the Capstone Design 1, where you have been studying, you have carried out your survey, market survey about your projects. Then after that, you move to second phases, where you will do the synthesis and preliminary design, where you come up with a few options or alternative of your design. Then after that, you choose the final design and you put it into more specification for that design. So in previous semester, you have been done all these things. You have done feasibility studies, you have done preliminary design, and you have come out with a final design. So for this semester, for this 2 weeks and 3 weeks, you will spend a lot of time in doing the detailed design. Okay, so meaning you start to look at the dimension, you start to look at the material, you start to look at the fitting to make sure that what you have designed is actually can be built and doable. Okay, so that is what's going to happen for this semester. So for phase of design, you have three phases. So what have you done in your feasibility studies? So basically, these are the flowchart for feasibility studies. So you start to gather information for the market, you analyze the needs and also the customer requirement, then you start designing. Okay, so feasibility studies, why do we conduct feasibility studies? Why do you, in Capstone Design 1, why do you do survey? Is to find out what is the market need, what does the market need, okay? So that when you design something later on, you design something that you can sell or something that you meet the objective of your prototypes, of your studies or of your design. If you go to work later on, you work in a design company, product prototyping development company, your final goal is to sell the products. Okay, so it's important you collect information during the first phase of your design and make sure as you progress on, you are designing towards the market needs. Because if you design something that the market don't need, you cannot sell. So when you cannot sell, you are not economically feasible. Okay. So this is what you've done previously. You have done the survey, and then during the feasibility studies also, you are actually looking at the technical area, what have been people developed previously. That's why you did the literature review, look at the available concept of the current technology that you have. Okay, so this is to make sure during feasibility study is just to make sure that the idea is doable. Okay, so in later you will conduct physical analysis, but this one, if you already have let's say you want to design a car, so basically if you're in the car manufacturing industry, basically what you do, you will do physical analysis, means that you will buy the competitors' products and you dismantle it, and you will look at what is the competitor strength and weakness of their design. Okay. So this is more commercial oriented. Mean after you graduate and you go work in the industry, this will be the main conversation between you and your boss, and your boss between your customer. Okay, because the price and cost of the products will affect the market penetration. And it is because when you done feasibility studies, you know what you need to invest, how much resources you need to invest. Maybe you need to invest a new equipment. Maybe you need to invest a new expertise. You need to employ new person in that particular area to solve that technical problems. Okay. Again, during feasibility study is to come up with a set of alternative. Right? The keyword is useful, meaning the design is really doable. Okay? It's really doable. Next is about initial initial synthesis, which is the second phase. As you can see, the flow chart changed a little bit. Okay, so when it comes to initial synthesis, so you follow all the process in these PowerPoint slides. Okay, so initial synthesis is the second phase of your design process. So you combine what you have learned, meaning your design team, the experience, the technology that you have in your company. Okay, then you start to look at the design concept. Okay, so after you look at the design concept, you have the 3D model, you have the drawing, the preliminary design, then you start to go deeper and deeper. Okay, so this is the phrase in Capstone Design 2, where you start to gather what you learned previously, and you start to look at your design concept. After that, you will done some analysis, you will run some simulation, and you will consider a few factors, for example, stability, sustainability, and then you'll do optimization, meaning something that you done previously, whether you can done it better or not. So there will be a return loop over here, and then you continue with the projection. You do after you do optimization, you continue to with the modeling, and if the modeling is not good, you continue back to the optimization process, and until you get the result you want, and then you present the proposal to the board of the company so that you can continue with the prototype plan. Okay. So during initial synthesis, it means that you are improving your design. You keep improving the design, and the output of synthesis process will be you're choosing the best design concept from what you have. Okay, so this is the synthesis process. So in here, we already mentioned about the mathematical model, the simulation, and all this. In here also, when you've done the simulation, you're doing optimization, you will choose the best material and geometry for the function, so that your prototype can function effectively and at the optimum performance. Okay, so during optimization, you keep adjusting the parameter in your analysis, also in your 3D model. Okay. Then when you come to the final phase, okay, you come to final phase is on the detailed design. Okay, detailed design means you keep look into the very small area. For example, what you will be doing for this 2 weeks times when you add more and more detailed dimension into your 3D model. What is the importance of detailed design? So once you have all the dimension, you have decided what material to use, you can prepare a proposal, a budget to the board meeting to present what is the resources you need to invest in for that prototype and go into mass production. Okay. So when it comes to detailed design, you will come up with a 3D model, you come up with lots of drawings, so that you can study whether this design or prototype is fabricable or not, or it's just a model in the software, and it's not possible to do. Again, to come up with a good 3D model and good drawing, it needs a lots of experience, especially technical experience in the engineering design. Okay, so I take you as a case study. So for example, you have learned a lot of engineering principle from year 1 until now. So you have been taught a lot of principle, you have been taught how to use the software. However, there will be some area that you might overlook. So how to close the gap in the technical experience? You need to do a lot of reading. Okay, you need to look at the most current handbook about your products, about your design. Okay. Then after the detailed design, the design team or your group will continue with the construction of your design, or in other words, building a prototype. So by the end of this semester, when you present your projects, what we expected is a working prototypes. Okay, it's a working prototypes. So if your prototypes, just a gentle reminder. So if your prototype does not work by the end of semester, it just means that you haven't learned the skill. So means that you fail to show that what you have learned, and you haven't you didn't achieve the learning outcome. So what we'll do is that you need to repeat the module again, right, until you appreciate what you learned, right, and show progress. So this one. So just give your hints for this capstone design to make sure your prototype is working. That is number 1. Okay. Okay. So this one just an add-on. Okay. In engineering design, you will keep on doing optimization. Okay. The next one, we'll look at design factor. So design factor, we can look at 4 dimensions. So when you design something, we look at performance, construction detail, safety, and cost. So this basically will be the main structure of capstone design projects, especially for capstone design 2. You will look at the performance of your prototypes, make sure it's able to work by the end of the semester. Okay, so when you do your presentation in week 14, make sure your prototype is working. Okay, so Then the construction detail. Construction detail means you're able to generate a good 3D model, and also you're able to generate a good technical drawing. And also in your report, you're also able to tell the user how to assembly your prototypes. Okay. The next one will be on safety and reliability. This one, since we are all engineers and we need to make sure that our product is safe to use, and also you do not bring any hazard to anyone who is around your prototypes. Okay, reliability means it able to work in the specified environment. Okay, so your prototype will have its own limitation. So make sure when you do your presentation later on, you should consider what is the limitation, what is the environment that it can be operate at the optimum condition. All right, in what situation it cannot be used. All right, so you have to specify specifically your prototypes. All right, how do you access safety? How you access reliability? The last one will be the cost. It is there will be a section. There will be a section in your report where you need to tell the reader how you control the budget and cost, how you come up with the calculation with the final cost or total cost of your prototypes. Okay. So this one will what will happen in here. So these are all the keywords. For example, under performance will be efficiency. Okay. Construction. Okay. This one before I forget. So for performance, since you already know what you need, what you are going to fabricate later on, make sure in your report, you mention something about efficiency of your prototypes. Okay. So you have been taught how to calculate efficiency. Means you compare your output and input of your energy. So you supply how many kilowatt, but come out how many kilowatt. Okay. Now both group you are using Moto, so make sure you are having that calculation. Right. Constructional detail will be all the dimensioning and all this, and selection of material. So for capstone design tool, when you generating the 3D model and also when you're generating the two-dimensional technical drawing later on, make sure you included the material inside the drawing. In 3D model, you need to define the material for that parts. Okay. Because without the material, you're not able to do any analysis. All right. Okay. Then after that, when you have the 3D model, you have all the dimension. The next steps will be, before you go into the workshop to fabricate it, you have to study and sit down with the group member to study how you fabricate the thing. This means you have study how's the production process. How do you get the component that you need to assembly your prototypes. Okay. Okay. Safety and reliability, in your report later on, or in your analysis later on, you will do structure analysis. So there will be a maximum load that can be sit on your prototypes. Okay. So this one will also be tested during your presentation. All right. So make sure you done your study properly. Yeah. And one of the things that when we look into your report later on, you have to know what is the most, what is the area that will take up the most of the stress and load, and what is the lowest safety factor in your assembly design. Okay, so you have learned what is safety factor. Okay, so in your report, I expect you to present what is the weak point of your design, what is the strongest point of your design. Okay, so how do you tell the safety factor of your product? You need to run simulation. Okay, so you learn about this one in one of your module. Reliability means that your product can continue to work under loading condition. Okay, the keyword here is randomness of loading condition, meaning let's say you're designing a Land Rover, a car that that uh, that can operate in the desert or in the river. Means that the driver can can drive in the desert, can drive in the winter, can drive in the wet condition. So that is the reliability dimension. Okay. The next one will be the cost. Again, if you're working outside there, this will be the defining factor whether your investor will invest or your customer will buy your products. Okay. When you're designing a prototypes, one of the hidden costs will be the maintenance cost. And also the shelf life of your products. For example, you buy a car, one of the costs that not included into the cost of a car will be the maintenance cost, right? So you need to make sure that your products come with a low maintenance cost so that you can penetrate the market. Okay. So these are the name that we will use for computer-aided techniques. So for example, CAM, computer-aided manufacturing, CAP, CAPP, computer-aided process planning, CNC, finite element, FE, and so on, virtual reality, and so on. Okay, so this is the classic flowchart of for the classic design process. It consists of two parts, right? One is the CAD drawing component, where you start from geometry modeling until 3D model. Okay, so you'll be experiencing this process during your optimization process, and also currently you are at here. Okay, so later you need to run finite element analysis and then do optimization, and then you do design assessment. Then you come up with a final 3D model. All right, so another side will be you start with the design process, do analysis, optimization, assessment, and presentation. So this will be the normal classic design that have two components here. Okay. What happens if you have the latest technology, or we call it synthesis design process? Okay, so what I mean by synthesis means that you're able to incorporate with all kinds of technology to make sure the design is success. Okay, so in here you will see you have human-machine interaction and so on, right? So the detail one, I will not go deep into this one, all right? And as you can see here from this flowchart, you will incorporate the virtual reality into the design process. Meaning when it comes to evaluation, you will present your 3D model using virtual reality, right? This one will be you'll be doing this in coming weeks, where you run the finite element analysis. You will construct the geometry and then you'll run the 3D modeling. So in the software that you use, for example, SolidWorks, you're able to view your product in wireframe and also in the 3D model, rendered 3D model. You're able to choose the presentation of your 3D parts, either in wireframe or in rendered 3D model. So this is another render format or STL format, where you change your element into all the standard shape for the triangular shape and also rectangular shape and square and so on. Okay, so this one, you see this one when you come into optimization and also when you do finite element analysis. You will do meshing. All right, I believe you learned what is finite element analysis before. So you need to do meshing. So you need to change all the parts or the dimension into small pieces of rectangular and triangular or tetrahedron shape, and then you calculate the stress on the component. So this one, you'll be seeing this one in coming weeks. So currently you are at this stage where you're generating the 3D model. Later, you will use the software to do analysis and you will see the projection of color, the stress color on your 3D model. Again, when you are generating the 3D model, there are lots of shape or fundamental shape that you can use to construct. All right. So nowadays, all the 3D models that are available in the market is very powerful. With 1 or 2 clicks, you're able to generate the shape of the model, right? Now, 10 years back, if you use a 3D model software, you need to key in a lot of syntax, lots of programming language. To generate a circle, you need to key in the mathematic model and then press enter and then create line and so on. Okay, so nowadays the software is very user friendly. By using icon and pick and drop function, you're able to generate all the standard shapes. And I believe you will also experience this 3D modeling process by using the chamfer, taper, shelling function in the 3D model software. So these are the things that you do during your geometric modeling. Okay, another revolve, for example, you use 3D model function to revolve a cylindrical model. Okay, so this one will be, I think you'll be familiar with this presentation. On the left is what you will see in the normal SolidWorks 3D model when you're done designing. This one or this window over here will be the one you see in the SolidWorks window. So you need to add in more cosmetic presentation when you do the assembly later on. Okay, so this one is the most basic parts in SolidWorks. However, when it comes to your final report later on, you need to make adjustment or add in cosmetic touch-up so that it look realistic. So that it look realistic. Let's say you want to generate aluminum plate with a hole. So this is what you will go through. Okay, so this is just a process by taking out this element to become a hole, right? So there will be steps on how you construct a 3D model. So each 3D software will run differently. However, the design concept is still the same, where you will select the face and then you want to cut out or you want to add something to it. Okay, and you can touch up with the fillet and so on. Okay, so and then this one, you will be doing this one for the next 2 weeks, where you will assembly all the parts together to become a single product like this. Okay, so each one of you, you have your own component to draw. So by, within these 2 weeks, what we expect from you is that you will generate a assembly 3D model, okay, like this chair, okay, over there. The next one will be, this one will be when you come to your final presentation. This one is more on the cosmetic touch-up. When you render your 3D model so that you mimic the lighting in the real environment. Okay, so you'll see a reflection, you will see shadowing on your assembly products. Okay. So this is what the 3D model 3D model software can do, and especially in SolidWorks software, this is a very strong point for them. Right, they are very good in the illustration of surface refraction. Okay, this one will be more on the rendering resolution. So when you do analysis later on, the higher your resolution, the better the results. Or, however, there's a drawback. The higher the resolution or meshing, it will take more times to do analysis. Okay. However, the rest resolution you pick, it will give you very fast processing process if you do analysis. However, the result, the accuracy will drop significantly if you take this one and that one to run the same simulation or same analysis. During optimization, you will get different results. Okay, you'll get different results. Just be careful when you come to meshing and rendering later on. Okay, so I end the theory part on the CAD design and some concern. Okay, so let me end the recording.